Hi, my name is Takuzo Ganre. I am a former A-level student and I graduated high school with straight A stars, and I'm here to help you do the same, or if not, just to make A-level maths a little less challenging for you. So in this video, we'll be looking at transformation of functions. Number 1. The graph of y equals f of x is transformed to the graph of y equals 3 minus f of x. Describe fully in the correct order the two transformations that have been combined. So in this case, we have this negative sign that is a reflection in the x-axis. So our first transformation, that minus sign, is a reflection in the x-axis. Then we have this 3 over here, which is a translation in the y-axis by 3 units. So that's translation in the y-axis by 3 units. So if you don't know the order in which transformations are applied, number 1 is always translation in x direction. Number 2 is stretch also in the x direction. Then number 3 is a reflection in the y direction. And number 4 is a stretch in the y direction. Number 5 is a reflection in the x-axis. And the last transformation is a translation in the y direction. So this is the order in which you always apply transformation. So number 1 is the highest priority, then number 6. So in our case, we have a reflection in the x-axis, which is over here at number 5, and then we have a translation in the y-axis, which is at number 6. So it means we start with the reflection and then the translation. Let's move on to number 2. The graph of y equals f of x is transformed to the graph of y is equal to f of 2x minus 3. Describe fully the two transformations that have been combined to give the resulting transformation. So this 2 here is a stretch in the x-axis, and it has a scale factor of 1 over 2. Always remember that for a stretch in the x-axis, we take the reciprocal of this number here. So since it's 2x, it means our scale factor is 1 over 2. And if it was, for example, 3x, it would be 1 over 3. And this only applies to a stretch in the x-axis. If it's in the y-axis, you take it exactly as it is. Okay. Now we have this minus 3 that's outside the bracket. That is a translation in the y-axis by negative 3 units. And this would be our final answer. We have a stretch in the x-axis by a scale factor of half. Then we have a translation in the y-axis by negative 3 units. Now let's move on to number 3. A function f is defined by x squared minus 2x plus 5 for x is an element of all real numbers. A sequence of transformations is applied in the following order to the graph of y equals f of x to give the graph of y equals g of x. So they say stretch parallel to the x-axis with a scale factor of half. So we have a stretch in the x-axis, and that's by a scale factor of half. Remember what we said earlier? We said if this number here is 2, it means our scale factor will be 1 over 2. So now we're working in reverse. We've been given that our scale factor is 1 over 2, so it means the number in the bracket should be 2. Then we have a reflection in the y-axis. So our reflection in the y-axis would be f of minus 2x. That minus sign represents a reflection in the y-axis. If it's a reflection in the x-axis, that minus sign would have been here. And then the last transformation is a stretch parallel to the y-axis with a scale factor of 3. So that's g of x is equal to 3f of minus 2x. So this is the expression that shows all the transformations that have been applied to get to g of x from f of x. Now the question wants us to find g of x, giving our answer in the form ax squared plus bx plus c, where a, b, and c are constants. What we can do now is we know that f of x has been given as x squared minus 2x plus 5, and we have created the expression that g of x can be written as 3f of minus 2x. So now we just substitute that, so it becomes g of x is equal to 3. So wherever there's an x in f of x, you're going to replace with minus 2x, so it becomes, let's put a big square bracket here, minus 2x squared minus 2, and then this x we replace it with minus 2x plus 5, and let's close the bracket there. Let's simplify inside the bracket. This becomes 4x squared plus 4x plus 5, and if we simplify it, it becomes g of x is equal to 12x squared plus 12x plus 15, and this would be our final answer. Now let's move on to number 4. The functions f and g are defined by f of x is equal to x squared, for x is an element of all real numbers, and g of x is equal to 2x minus 2 squared plus 3, for x is an element of all real values. Describe fully a sequence of transformations that maps the graph of y equals f of x onto the graph of y equals g of x, making clear the order in which the transformations are applied. So let's just start out by listing out the order in which transformations should be applied. So that's translation in the x direction. Then number 2, we have a stretch, again in the x direction. Then our third transformation is a reflection in the y-axis, and the fourth one is a stretch in the y-axis. The fifth one is a reflection in the x-axis, and the last transformation, number 6, is a translation in the y-axis. Now if we look at f of x is x squared, then here g of x is 2x minus 2 squared plus 3. So if we're to look at what's inside the square brackets first, we'll start by looking at that. We have x minus 2 squared plus 3, and we started with x squared, so it means here we translated in the x direction by -2 units, and then here we translated in the y direction by 3 units. Then we also have this 2 that's outside the bracket, that is a stretch in the y. So we'll start by writing the translation. So in this case, since we have two translations, we have a translation in the x and a translation in the y, we can combine the translation and say it's a translation by the translation vector 2, 3. And then our second transformation is this 2 that's outside the bracket, that is a stretch in the y-axis by a scale vector of 2. And those are the two transformations. In this case, you notice that translation in the x-axis takes the highest priority, and then translation in the y-axis is actually the last transformation. But since we've combined the two translations, we can write it as the first transformation, and then it's followed by a stretch in the y-axis, which is number 4. That would be our second transformation. So that's translation by a translation vector of 2, 3, and stretch in the y-axis by a scale vector of 2. So that's it for today's video. Thank you for watching.